Hey there, good morning, good afternoon, good evening, whatever time it might be where you are out there. My name is Jeff Fritz, and this doesn't look like Twitch. Welcome to another Pluralsight live event. We're going to be talking about Blazor today, and I want to talk to you. Yeah, Blazor, you got the Blazor hat working and everything. We're going to be talking about Blazor. I want to take about an hour. They told me I was going to have about 6 hours of time. I said that's way too much. I can't do 6 hours. But let's talk a little bit about Blazor today. Let's get in and see what's going on with all the cool stuff that's happening with Blazor and how you can talk about migrating your existing applications to Blazor WebAssembly and server. How you doing there, chat room? I don't see anybody. There's a couple folks commenting. Hello. There's Vince. And is that Munyard, is he? Hello, welcome in. Great to see everybody. I'm so glad that you decided to take a little bit of time, spend some time with me, and learn a little bit about Blazor. So, let me introduce myself. There we go. There's some slides. We're going to get started migrating existing applications to Blazor WebAssembly and server. I want you to understand there's two different Blazor models here. What makes them so compelling, what makes them so interesting, and how you can get started, move in the right direction, and I want to make sure you get some materials so that you can follow up on that later when you actually start working with your applications and you start implementing and working with Blazor. All right, so I've got my eyes on YouTube here. I got my eyes on Facebook, keeping an eye on what's going on there. Chat room, let me know. This is not This is not a Pluralsight video where you have to wait and comment sometime later in a forum in the stuff afterwards. No. Ask your questions now. I'm going to be watching that chat room, and I want to hear from you, whether it's on YouTube or Facebook. Those are the two places that I'm watching, and I want to help you out. I want to answer your questions and help you get successful with Blazor. My name is Jeff Fritz. I'm a senior program manager at Microsoft. I work on the .NET and Visual Studio teams, but I'm also a Twitch partner, a YouTube partner, and I'm a live coder. I write code live on those platforms so that you can tune in, ask questions, just like I hope you are today, and we'll talk to you and help make you successful, whatever it is that you're working on. And I might be known for something with coloring my beard funny colors, rainbow colors, because let's face it, if you're going to color your beard a color, don't just make it natural color. Let's go the full rainbow. Am I right? That's fun. That's kind of a thing we like to do. So let's talk about, well, okay, Blazor server. I kind of know what that is. That sounds familiar. But what's WebAssembly? Okay, WebAssembly, let's back up just a little bit here. WebAssembly is actually, it's abbreviated Wasm, but it's a binary instruction format for a stack-based virtual machine. Wasm's designed as a portable compilation target for programming languages, which means that it will enable deployment on the web for both client and server applications. Okay, that's from webassembly.org. So that means you can build with whatever your favorite language is, compile it down to a binary that we call WebAssembly, and deploy it and run it inside the browser using the browser's virtual machine. All right, now we're talking. Now that sounds interesting because everybody's got a browser. And if I can run my binaries inside the virtual machine on the browser, right, this is what makes JavaScript so compelling. I can build JavaScript applications and they work in the browser. Well, why would I choose this WebAssembly thing instead of JavaScript? Listen, it's like this. WebAssembly can be natively decoded by your browser, which means that instead of it having to go through and be interpreted, just like JavaScript, it needs to be interpreted, parsed. Experiments show that WebAssembly can actually, once it's on your browser, can run and be deployed 20 times faster than JavaScript, according to the WebAssembly docs and their FAQ that you see right here. So WebAssembly can be targeted by many different programming languages. That means whatever programming language that you're using, there's a really good chance that it's available to target WebAssembly now. Use what makes you happy, right? Now, you don't have to be constrained to just using JavaScript or maybe TypeScript or CoffeeScript and compiling down to JavaScript. Use what makes you happy. Use the tools that are going to make you successful, and all developers now can write code that runs in the browser. That's pretty cool. But, I mean, come on, Jeff. Let's get down to brass tacks here. Show me a little bit about what WebAssembly does. Let's get into this. There's got to be more to this than just write a little bit of code, compile it, deploy it to a browser, and it does a thing, right? So let's talk about that. Let's get into this. And let me show you. I'm not even going to go into Visual Studio yet. Hang on here. I've got too many other things running. Let's get over here. I have a browser already set up with some demos right here. So this is a set of demos. What the heck? It's these dancing skeletons. Look at this. What? These are running in JavaScript, okay? I'll give you the link to this. You can see it up here at the top if you can type it in real quick. But we'll drop that link into both the YouTube and the Facebook chat room so you can try this out on your own machine. But this is running as JavaScript, and I can control the number of these that are running, and you can see we're running a little bit less than 20 to 30 frames a second, and I can crank this up. Let's put a bunch of these out here. There's 74 of them, and you can see on my machine, this is an i7 7700, something like that from a few years ago. JavaScript starts to crawl. My frames per second, you see there in the top left corner, I'm down at single-digit frames a second, 4 frames a second. It's rendering and painting these dynamically on the canvas here for us. But if I flip that to WebAssembly, everything is smooth and groovy, and we're back over 30 frames a second. So the point that I want to show you with this demo is rendering graphics, 3D graphics, right? That's a pretty processor intensive. JavaScript might not be the right tool for that. WebAssembly, something that runs binary, that runs native inside your browser, is going to perform a little bit better for you. Okay, and there it's restarting the demo for us. Now, I don't know about you, but when I'm building an application, I'm typically not building skeletons dancing around. I don't see the business value of skeletons dancing around in my browser, right? This might make somebody happy, make them smile, but this doesn't create sales or anything like that. The next demo I want to show you is actually from our friends at Uno Platform. Now, what they've done is they've taken the source code, the UWP source code that was released and shared by Microsoft for the calculator application. And they've taken that C# and XAML and recompiled it using their platform that lets you use C# and XAML to target WebAssembly. Oh, that's pretty interesting. Okay. So we're not using Blazor, we're not using web technologies specifically, but we're recompiling into something that can be deployed as a WebAssembly application. So it's the Windows calculator, right? I can do Windows calculator-y things, and the point here is, right, it behaves, it looks, and it feels exactly like the Windows calculator. Now that's impressive because they've taken, lifted, and recompiled and something UWP, that's, okay, this is a simple application to recompile and redeploy it. You know, I mean, Jeff, calculator is a simple demo here. You know, show me something that's a little bit more complex. I mean, come on. Can you really, we rendered skeletons, we built a calculator here. Come on now. There's got to be something a little bit more interesting than just that shows, show me, knock my socks off. Show me that WebAssembly can really do something. Okay. Here we go. How do you feel about Doom 3? First-person shooter, built, what, 10, 15 years ago? And it downloads and runs in the browser. Now, this is the shareware version, and it was originally written all in C++. It's the GPL source code release of Doom 3, and it's been recompiled so that it works here in the browser. Now, I'm not actually going to get all the way through to showing you the game playing here, but I do want you to see that this is full fidelity of this game running at, and it's going to take a little bit here to load up, and you see my frames per second have dipped there. You can see that right here. But this is going to be up and running here in a second. We're going to start to see some of the animations for flying around in space, some of the amazing visualization from the folks at ID Software, but now running in the browser. Okay? We've stepped it up here. I mean, if they're able to build a game, take it, recompile it, and run it here in the browser, and get smooth animation, I'm not going to get all the way through to the interaction. There's something to this, okay? WebAssembly is something that's now available to you that you can use to target and build applications, okay? Now, are you going to build a full first-person shooter with 3D renderings and animations that you can run around and do all the things? No. Let's face it, many of us are building business applications. You're building things that folks need to interact with to do accounting, right? Do sales work, different analysis of data, right? You're not doing something like this. So let's head back over to the slides and let's talk a little bit more about what we can do with this, right? What are some of those next steps that we can do when we talk about my favorite framework and language, .NET and C#? So here we are. Typically, when you think of ASP.NET, when you think of .NET, C#, right? You've got some sort of a cloud over here with servers running in the cloud. Maybe they're nice little blue servers. See what I did there? And when you think of ASP.NET, right, you've got .NET running on the cloud on those blue servers. They're rendering some HTML and they're sending that data into the browser. And typically, if you want to have some highly interactive application, you've got Angular, React, or Vue, or maybe just plain old JavaScript that runs there in the browser, and you have these back and forth requests that happen. You're sending data back and forth so that you can have that interaction as things get saved. You can fetch data, whatever the case might be. Well, what if we can, instead of getting you writing with the same JavaScript in the browser, right? Now let's take WebAssembly, let's push that into the browser, and this is what we call Blazor. Okay? We're going to take .NET, we're going to run it in the browser, and we're going to use Razor. We already know things about Razor. Razor templating's been around for the better part of 12 years, and we're going to use that to format our content. So, Blazor, quick summary, lets you build client-side web user interface with .NET instead of JavaScript. You can write reusable web user interface components with C# and Razor, and that's important there, that second point. You're going to write reusable web user interface components. It's not just build a page for all the things. We're back to a component model, and you're going to see where that's valuable and where that's going to help you as we get a little bit further on into the talk here. You can share .NET code now with both the client and the server. So our friends that use Node have, a lot of folks have moved to Node so that they can have both their Angular, Vue, or React application on the front end and have the same primitives, the same objects living on the back end with Node, so they can share objects, they can share business logic, and have the same server-side logic run that's on the client without having to rewrite code. Now you can do that as well. You can call into JavaScript libraries and browser APIs as needed, so we can integrate with the full capabilities of the browser from inside of .NET. Right? I mean, it's one thing to echo some code on a rendered HTML page that says, right, JavaScript script tag and execute this command as rendered text that you're emitting from C# in an ASP.NET application. No, we're actually going to be able to call directly into those JavaScript libraries and APIs and interact with them directly. That's important, right? That gives us even more of that live interaction so that you can migrate and start consuming some of the great libraries that are already out there, interact and build cool things that behave and work with your browser, and be able to build effectively as a C# and .NET developer. Now, you have your choice when you build with Blazor. You can build either on the client or on the server. And when we say client, we mean what we call Blazor WebAssembly. So that means that you have a document object model, right? We know that. That lives there in the HTML browser. And you have a Blazor application that sits on top of it, just like your JavaScript applications would when you would build a single page application. And Blazor means you have Razor components that live on top of and run on top of a .NET runtime that runs on top of WebAssembly in the browser. Okay, so nice little stack. I can understand that. That makes sense. But Razor components on top of a .NET stack, that means I need to ship some .NET things down to the browser. Yes, it does. But it also means that we can do this on the server, because if we take those same Razor components and have them run on top of a .NET stack, well, if that .NET stack is .NET Core, well, we know how to use the .NET Core runtime. That's been around. They've been building that since 2016, and we're able to work with that and have it run on our nice blue servers in the cloud. They can send messages down, updates to that document object model in the browser, and we can update it with SignalR. We used to do this many, many years ago we had Ajax panels, right, inside of ASP.NET Web Forms, right? And there were different panels that folks had in Ruby and all these different frameworks, so that when things changed inside that square of content in the browser, it would automatically get updated and repainted using XML HTTP requests from the server. Same thing here, except you don't have to wire anything up. You don't need to find some sort of special component. There's a SignalR, what we call a SignalR channel, that'll do that two-way communication for you. As you click buttons, as you interact with fields, it will send those messages back to the server. And if there's something that the server wants to repaint on the screen, it'll send that message back to that browser and automatically tell it to update. It works exactly the same. And to note, that Razor components block that you see in both models is the same. You can use the same Razor components both on the server and in WebAssembly in the browser. Very cool to have that flexibility. Now, Blazor Server was made available as of .NET Core 3.0. That was back in September 2019. And Blazor WebAssembly was released just this past May. It sits on top of .NET Core 3.1. You'll see it with version number 3.2 in the stack. Now, in your project files. Now, Blazor WebAssembly is what we deem a current release. Folks in the .NET ecosystem will get current support for that until the next version comes out, and 3 months after that. And here in summer 2020, we know that coming out in November is going to be .NET 5, and there will be an update of Blazor WebAssembly that comes out at that time as well. Let me see here. Yeah, Pluralsight's kind of pushing along. If folks have questions, please interrupt me. I am keeping an eye on both the YouTube and Facebook chats. If you have a question about Blazor, let me know, and we are happy to pause and touch on your questions. Why would I choose Blazor Server versus Blazor WebAssembly? Blazor Server is great because it has a thin client. The entire runtime runs on the server, and you have the complete .NET Core runtime. You don't have to worry about where that gets shipped or if all the pieces are there, because it's all on the server. Blazor WebAssembly is great for offline support, progressive web apps, zero latency user interface, because you're going to deploy, you're going to push all of the content, all of the DLLs, all the things to run your application are going to be pushed down into the browser, and we're going to aggressively cache them in the browser so that you don't have to reload them from the server each time. Jeremy Morgan in the YouTube chat room asks, are there any ways of reducing the size of the packages sent to the browser over the wire when running in WebAssembly mode? Good question, Jeremy. So when we build with, and let me just skip forward there it is, .NET Core 3.1. When we build our WebAssembly projects, right, and you're working in development mode, they don't optimize. It's not going to do anything to really optimize and make sure that you get small, thin DLLs running in the browser, because that's an extra couple of steps in the build that when you're developing, you don't really care about. You want to be able to build as fast as possible and get in and inspect things. But when you do publish, when you do release your code and you go through a .NET publish process, it will actually do Brotli compression on the final DLLs. It'll do some tree shaking, and it'll do a Brotli compression on there, so it compresses those down smaller. And in some of the samples that we've been going through on the .NET team, we see it come down so that it's actually smaller than the amount of scripts that you download to use such online email applications like Gmail. So it's improving. It's not perfect, but we're getting there. This is still version 1.0 of this tool. So it's only going to get better as we learn how to optimize and we figure out those other places that developers prefer to use WebAssembly and what we can simplify to put in the box for you. Thank you so much for the question, Jeremy. I really appreciate that. Zoran on YouTube asks a question here. Can part of the app be run on the server utilizing .NET Core, and other parts run in WebAssembly to improve latency? So this is the promise of the hybrid app. Let me back up the slides here so you can kind of see. So we have these two here, WebAssembly running in the browser, server, right, Blazor server running on the server. Can we actually do a little bit of both is the question, right? Can we just ship down those pieces that we need to run WebAssembly so we get effectively a good first render, and then let WebAssembly take over, right? Or have some things that need to be secured, right? That you want to make sure are validated, right? And we see that sometimes in the pharmaceutical industry or the finance industry, healthcare industries, right? You have validated things that you need to make sure nobody touches, signed off, and in a completely secure environment. You need that running on the server. There aren't ways to specifically have a little bit of both. The .NET team wanted to hold back and see how much how much of a need, how much of a request there was for it. Because, like I said, this is still version 1. Let's push both models out there, see what the uptake is, figure out exactly where that can happen. And I'm going to show you when we get into the demos here, you can have WebAssembly listen on one set of URLs, and you can have server actually listen on a different set of URLs. So it is possible to grab both models here and have them listen on different folder structures inside your application. Is it something that I'd recommend? Not yet. It's a little bit confusing to kind of Borg together, if you will, and munch together the two models there. It's a little bit like how we used to have the Franken apps that were ASP.NET Web Forms and ASP.NET MVC. You could put those next to each other in the same application, but it gets a little bit dicey when you have to migrate things back and forth between them. Possible, but there's another level of sophistication you need to manage an application of that structure. So thank you for that question. Let's Nigel has a question about how do I get started in my first Blazor app? Spoiler alert, that's the next demo. And then how do I deploy it to production? I'm not going to get quite to deploying it to production, but I will show you the command. I'll show you the command line command that you can execute that will prepare your app to deploy to production, so you can just copy it and deploy to your favorite cloud service, your favorite hosted service, maybe an internal server that you're running. Is that Amismart asks, will the Blazor server make the browser slow because of so many things we are sending to browser? Let me come back to that question. The answer is no, it will not make the browser slow, and I'll show you exactly how it sends data back and forth. Let me skip forward here. Getting started with Blazor is real easy. So the question, going back to Nigel, was, well, how do I get started? Go to blazor.net. It's the .NET team that built this. It's Blazor, so the URL just made sense. Blazor.net. Make sure you pick up that it's an O in there. BLAZOR.net. I know us English-speaking developers are confusing the non-English-speaking developers by not making it spelled the same way as Blazor, okay? But it's an acronym. It's the combination of browser and Razor, and that's how we get Blazor. Download and install the .NET 3.1 SDK for Windows, Mac, or Linux, right? That's that command line interface so that you can build .NET tools wherever you build, well, .NET applications and use .NET tools wherever you might be, not just on your Windows, Mac, or Linux machine, your favorite continuous integration environment. Azure DevOps, GitHub, Circle CI, whatever it might be, you can run it out there. Jenkins, TeamCity. You can run these command line tools there and be very successful. So let's take a look at what the first app looks like and talk about components, and we'll even get into showing a little bit of not just Blazor server, but also Blazor WebAssembly. So I'm going to start my console here, and here it is. I'm in my dev folder. Now I can create a .NET application by just saying .NET new. I've got a bunch of templates here. These are all available for you to use. Most of them come out of the box. I don't think I have any that are specific to me here. No. But the ones we're specifically going to be looking at are these two. And I'm purposely using the command line here because if you're doing this in Visual Studio, there's a handy set of menus that walk you right through to building your first Blazor app. I'm going to show the Blazor server version of this first, and then we'll take a look at Blazor WebAssembly. So this is the noun that you use along with the new verb. So we're going to say .NET new, and the noun for the template we're going to use is either Blazor server or Blazor Wasm. So let's create a Blazor server first. So let's clear this, and I will run .NET new Blazor server, and I can give it a -o to specify what's the name of the folder you want to write this to. So I will call this PS Blazor server, and it's going to instantiate that template, create this folder for us, and put down the template, restore the packages that we need there, and I can jump into that folder and I see my content here. If you're used to seeing .NET Core, this kind of looks familiar, right? Because I've got an obj folder here. I've got a Jeff that can't type. I've got a dub root folder. I'm used to seeing that. That's where my static content lives, like CSS and my icon. And I've got some shared content here. I've got a data folder that has a model and a service sitting here. That's not bad, right? Startup class. I know what a startup class in ASP.NET is. If you're used to ASP.NET Core, this looks familiar to you because I've got a startup class that has a configuration object, configure services, and configure, because this is Blazor server. This runs as ASP.NET Core. It sits out there and it does interaction, rendering some content on the server and trafficking that data back and forth. Now, it traffics it back and forth, I said earlier, using SignalR. And here it is right there. This Blazor hub that we have listed. The Blazor hub is a SignalR hub that will do the two-way communication between the browsers and the server. This way, you have very stateful connections to your server, and you can remember things about the state of your user interface and send just those updates. You don't even have to think about coding those updates, but those updates will be sent back and forth to the browser. So let's start this. Let's take a look at what this actually is. So I'll just .NET run, just like you might do in any other .NET application. And we're going to get back to Smart's question here in just a minute. Well, does it make the browser slow? No, it doesn't make the browser slow. Wait till you see this. So .NET run, and this should pick up here and start running some code for me. There it is. And I'm going to go to localhost 5001. Let me open a new browser here, bring it over. Localhost 5001, and boom. I mean, that was almost instantaneous, right? If we take a look at what loaded here and we take a look at the network, I'm going to control F5. Take a look at how quickly and how small the entries here. Okay, look at the entries. 200K, is that our big one? Right? 460 bytes, 183 bytes, 31K. The total that we transferred was 400K. So we're not sending a lot of content because we're just painting this first page. And I want you to see the 101 connection here. This is a WebSocket connection, and it's sending messages back and forth to the server. Now, that's a little bit interesting. We're sending content back and forth, and you can see the data that it's sending. And the data it's sending is really small. So if I go through to this page, counter, you see it's sent back, right? Look, it sent this message back to the server. Dispatch browser event. Well, here's all the information about what happened. The mouse clicked and it tells it exactly where. Screen X, screen Y, the exact coordinates, and it sends back whether I held Control key, Shift key, Alt key, and it says, oh, at the location that changed, we wanted to go to this place. And look at it. I mean, these are very, very small entries. 136 bytes were sent back that told it, well, here we're going to render a batch. And here's the page that we just painted, that H1 and the count, right? And here's information about exactly the control, that click me control that we painted on the screen. But this was less than a K. That's really good, right? To get that much and have it repaint the screen. And as I go through here and I click this button, well, dispatch browser event, render batch, and it sends back, well, here's what you should be painting. And it gives it, here's the one that it is going to put in there. And it was, once again, less than a K. So to Smart's question, right, to make sure that we address that, this is very small interactions, right? We're doing all the work to render and the business logic. We're just incrementing a counter here, big deal. But we're doing all the work on the server and we're sending down very, very small patches. So if you've got customers, if you've got folks that are going to be using your application and they're on a bandwidth constrained network, this is great because I can click through and I'm not going to get as much interaction. It's not as much that I'm pushing back and forth. I click through to fetch data, and if we look at the messages here again, you'll see where it dispatched, okay, I clicked on another thing here and it sent back, well, here's some information that we need to render, and it actually went and fetched the content to paint on this screen and painted it. Right, here's some rendering information, and let's see, where's that last bit, right? All highly compressed, 3.4K. You can't read it here because it's all compressed, and it repaints the screen nicely for us. So as what I want you to see is that as the user interface changes, as we navigate around here, we don't have any additional pages loaded, but we have everything going across a WebSocket for Blazor server, so that we have very, very small payloads going back and forth. You can deploy a minimal amount of HTML to get things started, and just those updates make it traffic and handle things a little bit faster and better for folks. But you do have to wait for a little bit of network for that to happen. Now, if you're on a network, if you're on a constrained network and 3K is going to take you a little bit to download, a second or so, yeah, you might see a little bit of delay. If you have some very complex user interfaces you're shipping down with graphics and whatnot, it might take a little bit longer to ship down. But for the most part, you're going to see very, very fast. And it was no time at all for me to start the application and get into this because, right, it didn't even take me a second to reload the page. That's really good. I see another question here from Sajid. Are those files, will they grow in size as we scale up the app in real-world scenarios? In the server version of this, no, they won't scale up because you're only getting the changes to the user interface that need to be painted on screen, right? At the point that I click through to the fetch data, the stuff that was used to paint the counter page, that's not being served. That's not being held anywhere. It's been thrown out of memory in the browser, so I don't need to worry about that. It only shipped the stuff to paint the fetch data page. Now, I want to make sure you see how we do components here. So in a real-world scenario, it's only pushing those parts of the application that make sense for your application, right? That to refresh that part of the screen. So I'm going to open, I want to show you this in Visual Studio Code today because you can use, we opened Notepad to edit earlier. I want to make sure you are comfortable and you can see that you can use any editor to work with Blazor. I happen to like Visual Studio Code, Visual Studio 2019. We'll take a look at in a little bit as well. Now, we saw the startup, how it sets up the application and does all the things that you're kind of used to seeing in an ASP.NET Core application. But the actual pages, we saw a counter. We have this .razor file here. Well, what does that mean, right? .razor. So this is the Razor format, Razor templating engine that you can use to build pages and components. So .razor means that we can put @page up there and a route, and it will listen and respond on the /counter location. And I've intertwined my C# and my markup by just using the @ sign there, right? And it'll output whatever the current count value is, and that's inside my code block down here. It's defined as a field, and I've got this @onClick. So I've got a button that, because it has @onClick, it says, hey, C#, you're going to call this C# method increment count, and here it is defined, and we're just going to increment that current count. It automatically refreshes the screen for us. Nothing done here to define any kind of transport, any kind of protocol. It just does the things. Now, what's interesting about this is this works both server side and client side. So let's go and talk about Blazor WebAssembly. So I'm going to do the exact same thing. .NET new, this time I'm going to do Blazor Wasm, and I'm going to output this, and I'm going to call this Blazor Wasm. Okay, going to create the exact same application, has the exact same templates in it also, and we're going to deploy it into a Blazor Wasm folder. So let me head over there. So, and once we have you up to speed and you see how these two are the same, we'll get into a little bit more tricky stuff here. So let's start in this folder. So once again, pages, root, shared, and we look at pages, counter. Look at this. Wait till you see this. Right? You know what? No, let's open the project directly. And we'll take a look at this. Ahmed on Facebook says, is this technology like Silverlight? Will it die, or how will we assure from that? So here's the thing. Blazor WebAssembly is built on web standards. You can use this with any browser. This will work on Windows, Mac, and Linux. It'll work in Safari on your iPhone. It'll work on Chrome on your Android phone. It'll work in Opera. It's built on the HTML5 standard. No plugin needed. There is not going to be some tech CEO that says, sorry, we don't support that anymore. For them to say, sorry, we don't support WebAssembly anymore, means they no longer support HTML5. The HTML5 review board and the web standards bodies have added WebAssembly as a standard. It will always be there going forward. So this is something that you'll be able to rely on, and it's not going away. And because it's part of .NET Core, that means you're going to get at least 3 to 4 years support going forward on the current version. Now, you're going to be requested to update, right? You're going to have to update if you want to stay current and get current support for these. We'll enter into a LTS version within the next year and a half. You'll have full support for at least 3 to 4 years. And it should be also pointed out, making a comparison to Silverlight, did you know Silverlight was still supported up to this year? Actually, I think it goes through 2021, I think is when Silverlight support finally ends. Okay? So Silverlight was considered dead almost 10 years ago, but there's still applications being built and run on it. So the model is the same in that we're running binaries in the browser. However, this is on top of standards, so it works everywhere. No plugins needed, and HTML5 supports it. So let's take a look. I had a counter component that was sitting inside my server application, and this is the exact same thing, but it's running. Come on now. Where'd that go? This one. Put it over there. It's the exact same thing. Page counter, current count, button. It's exactly the same thing. Increment count is right there. Okay. And increment count with the click me, the exact same code, but this will work on WebAssembly. So let me show you that. I'm going to start this up. It's going to run on top of IIS Express, and we'll get the exact same experience with the exact same components across both environments. Now, I mentioned components means we can reuse these things. So let's get into that tech a little bit here. So notice the WebAssembly takes just a couple seconds extra to start. I'm using Firefox here, and we're going to open up Firefox, and you're going to see this will start up, right? It has to download now all the DLLs to run the application. Notice the slow to get it started, because to the question that Sajid had earlier, these files will grow in size because it's shipping the entire DLL, the entire application, into the browser. And when we look at what was downloaded here, right, I can show you it's actually loaded 6 meg of resources from the network. And you may be familiar with some of these resources because they're DLLs. Systemnet JSON DLL, right? System memory DLL, system XML link DLL. Look at these. You know what these things are because you'll have the exact same access and experience with those, but running in the browser. Nothing's being sent back and forth. This is all now running binary in the browser. And when we look at what's being sent down, we have a Blazor WebAssembly JavaScript that starts up, it bootstraps everything for WebAssembly. And there's everything to get our .NET framework running right there as a little bit of JavaScript to kickstart the WebAssembly and the .NET framework that are running here in the browser, right? So there, it loaded a little JSON file off the server. We had a slight delay, and it painted on the screen. So we have these components we can start to reuse and do a little bit with. And when we think about components, we don't want to have a lot of ceremony with them. We want them to behave quickly and easily. So I can take my counter and include it in other pages just by referencing a counter tag. So run that, and now I have a counter that lives as a component sitting inside my index page. So it takes a little bit, and there it is. There's my counter below the welcome to your new app. And all I did was just reference it. Every one of these .razor files, it's a Razor template, right? You know how to use those. They become components you can reuse in other locations. And if I go back to my counter here, if I take that @page syntax off of it and I restart the application, right, it redeploys, and now it's just a component. It's not a page. It doesn't have a route that it knows how to answer on. So this still works, but if I try to navigate to counter, well, that thing doesn't exist. There's nothing there. So it comes back with a message because that doesn't exist. So at page at the top of your Razor components, make something into a Razor page, right? Into a Blazor component that you can then access directly. Pretty cool. But that's just the tip of the iceberg. We can do a heck of a lot more with components, and I want to talk to you about them. Let me get back over here into the slide. Our Razor components, they're like MVC views. We already saw a little bit of this. They're actually a little bit like Razor pages as well. You can use the Razor template language in your Razor components. You saw it's a .razor file instead of .cshtml. View models can be easily connected with a CS extension. So we had counter.razor. Well, we can also create a view model that lives behind it at counter.razor.cs. And Solution Explorer will update appropriately and reflect that relationship. And you can then unit test those view models directly because they're just a class. They're not markup mixed with code. Some folks really like that. Folks who are particularly comfortable with using React, they like having their views and some of their business logic mixed together. That's okay. If you like doing that, you can do that. You can program that way. If you don't, you want to keep things separate, you have that flexibility as well. And if you want to test your components, the actual rendering and the output, you can use a library like BUnit from our friend Eagle Hansen. That's available out there on NuGet. You can download that and build an application that will allow you to unit test your components. So let me show you a little bit about view models here. I'm going to go back over to my code. So, right, we have the counter here. Let me put that page back up at the top. And if I want to put a view model with this, I can move these things out and create a class here. I mentioned counter.razor, spell razor correctly, Jeff, razor.cs. And there it is. And at this point, it starts to feel a little bit like web forms. Just a little bit. I can make this a public partial class, and now that underline goes away, and I have a class that I can interact with from my counter. And I can get rid of this code, right? Let me get rid of that. I can bring it over here, and from my page over here, I don't even need this code block at the bottom. Now I've got just a view, and it knows what increment count is because it's coming from the other half of this class inside this partial class. Now, right, this does come off of, if you needed to inherit, it comes off of what's called the component base, is the base class that all of our Razor components come off of. If you're just doing a partial class, you don't need to specify that inherits, okay? You only need that if you're going to do something a little bit extra. You're going to be inheriting from something else. Maybe you want to have your own base component that can contain some formatting, some other things. You can do that, but it's a component base is where this starts from. And this still works. I just moved things into here, so now I can put all of my actions, I can put all of my methods and properties over here, and it still behaves the same way. But it's over inside of my view model behind the scenes. So that's pretty cool. That gives me a way to organize my code a little bit, make it nice and tidy so that I don't have to go chasing, right, into each one of these files to see if the code's actually working, right? I can look at my classes. I can test these classes directly using XUnit, NUnit, and reach into a class object directly. Now, you can also take your components, you can put them in a class library. They call it a component library project type. You can add that and reference that. I'm not going to go through that sample. I want to get through and talk to you about web forms here in a second. But all of these things are just classes that you can put into separate libraries and compile as a NuGet package so you can share them around to some of your friends, some of your colleagues, and you're even seeing the component vendors, the DevExpress, Infragistics, Progress Telerix of the world are making NuGet packages containing these components that you can use in your Blazor applications. and they work on both server and client as well. Really, really good to see the growth and the evolution of our ASP.NET ecosystem. Let me head back over to the slides and let me get through. I want to talk to you about how this impacts with web forms, right? Because there's millions of web forms applications out there. They're actually pretty similar when we think about this, right? Web forms is that old ASP.NET technology, the .aspx files, the .ascx files that were controls. In web forms, you built an application out of this global ASAX file, right? That was where you configured your application and you told it, here's what happens when the application starts. Different application events all get managed in that global ASAX. If you're with me here, chat room, you know that was a pain in the neck to manage and to work around. My goodness. You had pages and controls you built in web forms. You built with raw HTML mixed with controls, is what we called them in web forms. And you rendered all of your content on the server, but you would interact with and execute with JavaScript by sending down text that said execute this JavaScript. Well, Blazor server side, you configure your application in Startup CS. You have components that can be pages, not necessarily having two discrete objects, right? That one, you have one component object and you can have it listen on an endpoint, on a folder location, right? On an address, just like it would be a page. So you have one object that can handle both instances. You build with Razor templates and components, which folks are much, much more comfortable with these days, instead of the old web forms notation. Render content on the server, just like in web forms. We know that. And we can execute and interact with JavaScript. Now, how are they different? Well, we had that bee sting notation, right? The percent tag notation. That was a pain in the neck to work with. That wasn't standard by any shape or form. People would open files and see that and cringe. View state, right? I feel like view state is a bad word here that folks don't want to use, because it managed and remembered the state of your pages between requests, and it would get huge. You'd have this huge block of data you'd be shipping back and forth, and ugh. Post back, you'd send all the content of the page back to the one page that you came from and have it processed, and you had all these events that would handle it, right? Master pages, and it lived through .NET Framework 1 to 4, and everything had to be written in .NET Framework, and it had to run on Windows. So kind of constrained there when you think about it. Blazor server side uses Razor files with the @ notation. State is managed on the server. You don't have to send state back and forth. It's done for you all on the server, and you have that SignalR channel. No postback. Everything happens through WebSockets. You have layout components now instead of master pages, and that allows us to define our layout using that same Razor technology. And it's built on top of .NET Core 3 and later, with components built targeting .NET Standard. So those same objects that you may have built, business objects, business logic that you've built that targets Xamarin or WinForms or web forms, if you make them into .NET Standard compliant libraries, you can use them with Blazor server-side and Blazor WebAssembly for that matter. This means it also runs on Windows, Mac, or Linux. Huge! That means you can also deploy into a Docker container and deploy quickly and easily. So how do you get ready for Blazor if you have a web forms application? Well, you want to get all of your C#, you have some architecture concerns first. Your C# is going to end up getting moved into Razor templates. So we need to figure that out. You want to get your code .NET Standard compliant. You don't want to be tied to anything that is Windows specific. Okay? So there are ways to do that so that you can be .NET Standard. There is a Windows compatibility pack that you can use as well that is .NET Standard compatible and will help you work. And there are some third-party control libraries that don't make it over into Blazor from some of those control vendors that we mentioned. They have upgrades that are Blazor specific that you'd be able to migrate and continue using. Your code, if you reference HTTP context anywhere, you can't use that in Blazor. You don't know what your HTTP context is. Get away from that so you can be a little bit more portable. If you do any kind of data binding using that eval data binding syntax, right? %pound eval. Ugh, that's a pain in the neck. You're not going to be able to use that. Any find control methods that you have where you're going down the stack and say, go find this control, update it. You can't do that either. And page events, they don't happen inside of Blazor. So let me show you real quick an application that we migrated to Blazor. and then we'll show you a experiment that we've been trying that's going to get you there a little bit quicker than you might think. Let me make sure I have the right version here. We are going into, this is, oh my goodness. I'm blanking on the name of my sample. Blazor eShop, or eShop on Blazor. I think that's it, right? Let me just double check. Nope, that's not it. I forget what the folder name is. I'm blanking on this. My apologies. I believe it was eShop on Blazor, right? Yeah, eShop Blazor. I had it right. I knew what I was doing. And I'm fat fingering it all over the place. Here we go. So let me go to the beginning of the demo. There it is. Now, I'm going to open this up in Visual Studio and show you what the existing application looks like and how we started migrating things over. Because this is an important set of steps here, because we all want to be able to migrate and keep our applications current. We want them to behave and have the latest and greatest technologies, and as the web advances, you want to be able to migrate and use all those cool things. So this is a simple storefront, and I'm going to focus on the default page here. This is ASP content, right? It's inside of a master page, and it's got a create new button up at the top and a list of products that are inside of a list view control with some layout and some items that are output inside of a table. When we want to take that and move it into Blazor, we end up with something very similar. So we have our create new button, we have a model that we're injecting for some service as a catalog service here, so we'll get that data, and we have a table, and we're going to output our rows here, and we have simple interactions, and down here at the bottom we have all the methods to go get data. Load page is calling catalog service, get catalog items paginated. If I look back at my web forms, I can do the exact same thing with model binding. In page load, right, get catalog items paginated. It's the exact same thing. But because our data is something we can make .NET standard, we pushed it out somewhere else. Let me just jump right to the end of this demo. I'm going to go to finish demo. There we go. And you're going to see we update all of the web forms code. We push things out. There's a shared project that we push things out to called eShop lib, and I'll give you a link to this Git repository so you can take a look at it. And all of our business objects we pushed out here. The view models for paginating our items that were in web forms we pushed over there. And my Blazor, I actually created my own component called a list view. It's sitting right here, and it does the exact same thing as the list view that I had over here in web forms. So I've got a start here of something that feels and looks the same. So we experimented with this and we started writing our own components that look the same so that we can try and get folks migrating and using Blazor a little bit easier. We call these Blazor Web Forms components. We conceived these actually on stage at Microsoft Ignite 2019. And this Shim library will give you the exact same markup and have the exact same markdown inside your components, inside your application. And because we know what the source code looks like, it'll just work, just give you that. And there's a bit.ly link so you can try them. The code, like I said, is very similar. We have ASP list view. We have all of the code here looks pretty much the same. Item type is catalog item. There it is, catalog item. We have to put a context in here so that Blazor knows, well, what's the context of this thing we're data binding? And our code for each one of those entries is very similar, except instead of having the bee sting notation, we change it to the razor notation. And it's still item.name, item.description, blah, blah, blah. It's behaving the same. So I want you to check that out. I want you to be able to take a look at this. We've built a handful of these controls already, including support for the same syntax that's in the data binder and the same syntax if you used an accessed view state directly. All right. So the idea being, get migrated into Blazor, start trying to get your web forms applications into the new technology so that you can take advantage of the latest features being deployed on the web. Build more portable applications that aren't web forms. A couple resources for you here. Folks asked some questions about WebAssembly and is this something that's going to be around for a while? Is this just the next Silverlight? Check out the WebAssembly specification. This isn't a Microsoft thing. You can find it at webassembly.org. There's a great set of demos out there for WebAssembly, including that Doom 3 sample. It's on the awesome WebAssembly list. Check it out at github.com/mbasso/awesome-wasm. Get your hands on Blazor at blazor.net. And the awesome Blazor list. This is a list of great resources, including components, samples, tutorials, walkthroughs. github.com/adriantorres/awesome-blazor. And if you want to take a look at those web forms components, they're an experiment that's in flux. We're continuing to build on those. Go to bit.ly/Blazor web forms components, and you'll see the team working on it there. We're continuing to add new features and trim and make them behave a little bit better every day. All right, my name is Jeff Fritz. I've gone a little bit over here. Thank you so much for joining me today. I'm happy to answer any questions you might have. I'm keeping an eye on Facebook. I'm keeping an eye on YouTube here. If you have any questions, drop them in there now. I'll stick around for a few minutes. And this is recorded. It'll be available on the Pluralsight YouTube. It looks like they're available also on Pluralsight Facebook after the fact here. But the time's yours. What can I help you with there, friends? I'm going to keep an eye on the chat room. There we go. I don't see any new messages from Facebook. I know there's a little bit of a delay. There's about a 30-second delay. 30-second delay. Emilio on YouTube asks, imagine you create a service where you save the current count. How do I get it working without registering the server side as a singleton? This problem doesn't exist when using client side. How do I get it working when registering the service? You're trying to persist it. You want an application state. So if you have an application state, you can save that as a singleton. You can deploy that on the server, just like you do with WebAssembly. Just like you do with ASP.NET Core. You can, this is WebAssembly. Let me go back to my server side. So inside of, wait, that's the wrong one. Yeah, here. We have, no, that's not the WebAssembly one. Here it is. Haha. All right, so we have a startup for server side. You can create an application state object and register it here, just like you do this singleton. So if I create my own class down here, let's create this, right? Application state, right? And the question was around that content count. So, the counter, right? Let's call it counter state. And let's default it to 0. I can register that as a singleton here, right? Add singleton, application state, there it is. And that's now available to me when I go and build my other pages. So if I go over here to counter, if you remember from your ASP.NET Core, I can inject, and this is the type that I'm injecting, application state, and I'm going to call it app state. So I've injected, I now have an app state object that I'm starting with here, and I'm going to set my, instead of having current count here, I can say app state, right, counter state plus plus. So now it's incrementing it, and it's in that shared state that I can pass around. And I can also take this, put it right there, and it will maintain that state and pass it around for you. There's a question here. It says, what about deploying to production? What's that look like? So if we're deploying to production, let's do the WebAssembly version first. You're going to end up running, if you're in Visual Studio, there's a right-click deploy button you can use. But most folks want to be able to build at the command line so they get the exact same build experience. And we do that with the publish verb on the .NET command line. So let me go to PS Blazor WebAssembly. And from here, instead of doing .NET build, I can say .NET publish. And this will give me a static website, right? Well, this one actually runs on top of, this template runs on top of, no, this is a static website. There are versions of the WebAssembly template that run on top of ASP.NET Core. This one runs on top of a static website. So I'm going to be able to go down into this folder and get just the things we need to deploy. So if you want to deploy this out to an Azure static website, you want to publish this to Elastic Beanstalk, to a Docker container, you can do that. You'll be able to copy just the output of this publish folder. There it is. Right? Debug.net. I'm going there to the publish folder. There it is. I have a www root and a web config. If I look in www root, I have CSS sample data. Where is it? Where's everything to run my application? It's inside framework. Check this out. Blazor boot JSON, Blazor WebAssembly. There's the things to get it up and running. And there's my underscore bin in Wasm. So if we look in bin, there's all the things to run .NET. They're all there. And there's my application, 17.9K as a DLL. These DLLs do not run on your machine. They run in the browser. They're going to be served. So really cool for you to be able to lift up and just put that either into a container or deploy it right to your favorite hosting service. So I hope that clears up a little bit there for you, Nigel, and shows you just how easy it is to build this. Now, right, I just did .NET Publish. There's, of course, just like with ASP.NET Core and other .NET Core application frameworks, I can pass in a configuration. I can pass in a target runtime that you want to be able to compile this and run towards. Target runtime isn't going to do anything for you when you're targeting WebAssembly because the runtime is WebAssembly. But right, if you were building a server-side one, you could target and say, well, make sure this runs on Mac OS. Make sure this runs on Linux, right? You have that flexibility as you build them. So you publish and bring your runtime with you. Just like we brought the WebAssembly runtime right there. So, very good questions. Let me take a look. Is that David Andrani? Hello, good to meet you. Thanks for tuning in. They're on Facebook. Nigel's good. Visual Academy, you're welcome. Thank you on YouTube. Great to see you. John Peter asks, why is Pluralsight plugging? That's for Pluralsight. They want to make sure that you have the skills to get interested, get up and running with Blazor. So I'm sure there's a number of courses on Blazor in the Pluralsight catalog. All right. I think that's going to hold for just another minute here for any other questions. And you're watching on Twitch. I didn't know we were on Twitch. Fantastic. I'm glad to hear that we're on Twitch. Love me the Twitch. So, all right. Well, thank you so much, friends. It was great to spend some time here with you. Thank you to our hosts at Pluralsight. I appreciate you inviting me on to spend some time with your audience. My name is Jeff Fritz. Let me make sure I go back to that resource slide one last time as we wrap up here. Check me out. I'm available on YouTube, Twitch, GitHub, Twitter. I am C# Fritz. You can find me in all those different places. Thank you so much for tuning in, and I will see you next time. Take care.